Hello auditors, today we are going to go through Gatekeeper One challenge. It's an Ethernaut challenge by Open Zeppelin. Over here, you can see that this is a contract, and in order to pass this challenge, basically we just have to make past the gatekeeper and register as an entrant to pass this level. Now, over here I've copied the contract and placed it here, and I've wrote some examples. So this is the attacker contract, and this is the actual contract that I've pasted to, and you can see that there are some gates, so we have to pass 1, 2, 3 gates, and then this is an example that I've actually abstracted it so that it is easier for you to understand. And then we have to submit the gate key so that we become the entrant and successfully pass this challenge. So firstly, I'll explain what modifier 1 is. So basically, the one who called the contract, which is this contract, must not be an EOA. So this challenge is very similar to the telephone challenge, which you can go and watch it. Then guess gate 2, this modifier gate 2, the second gate, basically the guess left must be a multiple of 8191. You can see there is a modulus of 8191. So it checks whether the guess remaining is a multiple of this. And if it's true, you pass this gate. And then over here we have gate 3, so it takes in the 8 bytes of a key, and then it must solve these 3 conditions. So over here you can see that I've actually converted this UN64 gate key into K to make it a simpler context for understanding. And you can see that this first condition, it requires the UN32 of gate key K into equals to UN16K. So it's actually quite simple, and for the second condition is basically UN32K not equals to UN64K. And then lastly we have UN32K must be equals to this particular transaction origin. So it's actually quite simple. So over here, let me just draw it out. So this particular attacker contract is quite simple. We have this simple owner, gatekeeper. So this event value will be emitted to show what is the guess value, which I'll explain later. And then we have this only owner modifier and a simple constructor so that we can interact with this particular contract using the interface. Okay, moving on, let's go down to the attack function. You can see that this is actually very simple. Let me explain what this does. So basically, for the second and the third condition, I've actually merged into one. Why? It's because that the UN32K, which is basically this K, is actually UN64. Let's say that K equals to UN64. And since just you have to convert it into UN16, so it's actually very simple. And then over here, since it requires it to be this UN16 of 160 transaction origin, we can just make it like this. So therefore, these two conditions has been passed. Let me just change my color. Ta-da. Now left the second condition, which is the last one. You can see that it requires it for UN32 not equals to UN64. So what we can do is we can actually make a binary representation. So for example, this K16, this is an example, this is not related. Let's say that K16 is OX 10234, so basically this is a hexadecimal. When I convert it into a binary representation, this is a binary representation. And when we shift it to a 63 bits using this particular operator, this will result into this particular binary representation. So over here we have this UN64, basically convert K16 back into UN64, and when we add both of this and this value together, you will become this. So what this does that is that it ensures that our UN32K is not equals to UN64. Why is this so? So for example, let's say that over here, actually, I just use this example. This is much easier. So because we have to convert back into UN64, so let's say that this UN32, and when you convert into UN64, it becomes 0, 0, 0. You can see that this is 0. And since the original part, which is 64, there is an 8. Let's say there's an 8 here, and when you convert back to 32, you have become this. So let me reiterate. So basically, we have this uint64. Let's say this is uint64, and when you cut it to 32, it becomes this. And when this uint32 convert back to 64, there will not have an 8. Oops. It becomes 0. And since there isn't it's not equal, the 8, basically the 63rd bit is not the same as this 63rd bit, therefore you have successfully passed this condition. So moving on, so to pass gate 2, we basically have to make it the guess remaining multiple of 8191, and over here we can see that I've actually created an ABI and I stored it into this variable, and that you can see that we need to play with the amount of guess. So instead of trying to calculate using the low level functions you can see in other YouTube videos, we actually can just brute force it. It's actually very simple. So this is a simple for loop that we can iterate 200 times. Wait, let me just move this. Right, and you can see that, for example, if the result is true, so basically the guess remaining is equals to 81 as a multiple of 8191, you'll actually call this function and then we'll pass in the key, and you can see that the key value is actually emitted over here, and then we will actually successfully solve this challenge. So let's go to the Brownie script. You can see that basically just in a contract your hacker account, we can check the balance, and then we can just deploy this attacker contract and just call this simple function, which is the attack function. And since this attack function has the interface of this particular contract, we can actually just solve this particular challenge easily. Now, before we move on, we have to make sure that we are actually using Sepole. The testnet is because that currently Gorally there's a lot of people using it and the gas fees are extremely high, as you guys know it. And then we'll just move on to using Sepole. So since I've actually added it, you can see that there'll be an error. Yep, it's actually quite simple. Just use this command and you'll add Sepole to the Brownie network. And now actually just run this particular script. And you see that we are actually successfully solved this challenge. Oops, let me just remove this. Let me just remove this and then this. Okay. So over here, I'll just pause the video for now. Okay, you can see that the transaction has been completed, and you can see that this particular for loop has been run for 106 times. So over here, let me just further explain. So over here, this is 106 times plus 150 offset. So what this offset does is that just in case that it requires a buffer for extra gas, this can be used. And okay, let's move on. So what is this particular key value? This is basically the 106 times. Let me just move up. It just emits a simple how many times the particular iteration has been looped. So since we know it's 106 and we have printed it out over here, so it has been looped 106 times. So now let's just submit the instance and complete this challenge. Yep. And also, if you guys require Sepole faucet, you can just go to this particular domain, sepolefaucet.com, and you can see that you actually get one Sepole, so basically one ether instead of Gorally, which now requires you to put 0.01 ether. And now, let's see if we have solved it. Tada! We have solved it. So guys, thank you for watching, and have a nice day.